All right, lesson 5.3 is going to be all about graphing and interpreting data and our measures of variation. So let's jump right into our vocabulary. The range of a data set would be the difference between the extremes in a data set. Now extremes, when we say the word extremes, we just mean the highest value and the lowest value. So if our data set was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the highest is 10, the lowest is 1. Those would be our extremes, our maximum and our minimum. When we say difference between them, that means we are subtracting. So the range between 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 would be 10 minus 1. We would say it's 9. The range is 9 in that case. A box and whisker plot is a method for displaying the median, the quartiles, and the extremes of a data set. Now median we've already talked about. Again, that's just the exact middle of all of our data sets. Extremes we talked about, that's our highest and our lowest. And the quartiles then, if the median is the exact middle, then it would break all the data into a higher half and a lower half. The quartiles are just the medians of those halves. There's a lower quartile, it's the middle of the lower half. There's an upper quartile, it's the middle of the higher half. So that would be each of those pieces, the median, the two quartiles, and the two extremes. The interquartile range, or the IQR. This would be the difference between the upper quartile, quarter 3, and the lower quartile, quarter 1, or Q1 and Q3. So again, after you cut all your data set in half, you cut each of those halves in halves, and that's how you would find Q3 and Q1. Take Q3 minus Q1, that'll be the interquartile range. A 5-point summary. This would be a summary of the spread of a data set made up of the lower extreme, the lower quartile, the median, the upper quartile, and the upper extreme. So if you'll notice, a 5-point summary is shown on a box and whisker plot. It has the median, the two quartiles, and the extremes. Again, we can see lower extreme, upper extreme. So the two extremes are there. Lower quartile, upper quartile. Those are both on there. The median as well. A 5-point summary is just a statement saying each of those numbers. A box and whisker plot is an actual graph showing all of those. Standard deviation. It is a measure of the spread by looking at how far each observation or each data point is from the mean. So if we were to take the average of all of our numbers and we wanted to find the average of how far each of our numbers is from that average, that would be the standard deviation. Again, what that means is we just want to know how far each of our data points is from the middle, or at least in general, how far they all should be. Now, whatever our standard deviation number is, if you were to square it, so multiply it by itself, that is what's called the variance. So let's get into box and whisker plots. In a set of data, the quartiles are values that divide the data into 4 equal parts. So if we look at this set of data, 23, 24, 29, 30, 31, 33, 34, 35, 39, and 43. There are 10 pieces of data. So if we were to cut it exactly in half, it would be right here. So our median would have to be in between 31 and 33, which means our median would be 32. Now, looking at our upper half over here, out of these 5 numbers, our upper quartile would be 35. Again, it's just the median of this upper half. Looking at the lower half, we have these 5 numbers. Our median there, the lower quartile, would be 29. It's just the median, or the middle, of these 5 numbers. If we wanted to find the extremes, our lowest value is 23, our highest value is 43. We now have our 5-point summary. 23 is the lowest, 29 is our lower quartile, 32 is our median, 35 is our upper quartile, and 43 is our max value. All 5 points are shown here. We can see each of them. So this would include, or this would cover our 5-point summary. Now, to make a box and whisker plot, you would draw a box around the quartile values and lines or whiskers to represent the values in the lower fourth of the data and the upper fourth of the data. So when we say our median is 32, we would find 32 and put a dot right there. Our lower or minimum, our extreme is 23, put a dot at 23. Our highest is a 43, put a dot right at 43. Now we would look at our two quartiles, 29, put a dot, 35, put a dot. All we do to create the box and whisker plot then is take these 4 points, or 5, 1, 2, 3, 4, 5, put a box around the 3 in the middle. So it's going to look something like this. Box there. Put a line right in the very middle, because that's the median. So our exact middle is here. Upper quartile, lower quartile. Take these points and just connect it over to that dot, connect it over to that dot. What this graph is showing us is that all of the data has to be within this range. This is the lowest data there is, this is the highest data there is. This is the exact middle, and so this is kind of the middle of the middle. All of our middle values should be somewhere in here. If you look at just our data, cutting from here to here, most of our data should be right in this middle area from 29 to 35. And that's what these dots are showing us, 29 to 35. Let's look at an example of how to make our own box and whisker plot. Now it says the amount spent in the cafeteria by 20 different students is shown. So there are 20 different numbers here. Each one is showing how much a student is spending at the cafeteria. We need to give the 5-point summary of the data and display the data in a box and whisker plot. We'll use the number line below. As well, I have already written out all of the data from lowest to highest. We have 3 ones, 1.5, 4 twos, 5 2.5s, a 3, a 3.5, 4 fours, and a 5.5. So we can already see our lowest value is 1, our highest value is 5.5. Now if there were 20 students here, we would be able to just count in 10 data points, put a line, and that'll be our middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here is our median. Because again, there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points on this side. 10 over here and 10 over here. So this is our median. Luckily, this median is in between two numbers that happen to be the same. They're both 2.5, so we know our median is 2.5. Again, we know our lowest is 1, our highest is 5.5. We're only missing 2 more pieces of data, the lower quartile and the upper quartile. If there are 10 over here, we need to count 5 in from either side and put a line. That'll be our lower median. So 1, 2, 3, 4, 5 right here. Because 1, 2, 3, 4, 5 are over here. So our lower quartile is going to be in between 2 and 2. So it obviously has to be 2. Our upper quartile, we're also going to count in 5. 1, 2, 3, 4, 5. So then 1, 2, 3, 4, 5 data points are over here. Our upper quartile, we're going to have the median of these two. The problem is we've got a 3.5 and a 4. So these are not the same number. So to find our median, we take the average of these two numbers, 3.5 and 4, and we'd find that it's 3.75. This means our 5-point data summary would be 1, 2, 2.5, 3.75, and 5.5. That shows our two extremes, two quartiles, and our median. Now we need to make the box and whisker plot. We're going to put 1 dot for our lowest extreme, 1 dot for our highest extreme. Our lowest is 1, our highest is 5.5. We need to do 1 dot for our lower quartile, right here at 2. We need to do 1 dot for our upper quartile, right here at 3.75. Lastly, we need to do 1 dot for our median at 2.5. Now we need to make a box that goes around our 3 middle pieces. Draw the line that goes through our median. Now again, this box, it kind of has vertical lines here at the upper quartile, here at the median, and here at the lower quartile. So this box has lines going through each one of them, not just the median. Now we just connect lower quartile to lower extreme, upper quartile to upper extreme, and we've made our box and whisker plot. As you can see, all of our data needs to fall in between 1 and 5.5. Most of our data, kind of the middle area, will be in between 2 and 3.75. Our exact middle will be at 2.5, which is exactly what we found. So this would be creating a box and whisker plot. The interquartile range, the IQR, remember it's the range of the middle half of that data. It contains 50% of all of the data in the set. To find the interquartile range, we take the upper quartile minus the lower quartile. So what was the IQR, or the interquartile range, of our amount spent data? Well, looking back, we would need to take 3.75 minus 2, upper quartile minus lower quartile. So 3.75 minus 2 means our interquartile range is 1.75. All, or 50% of our data is only going to be $1.75 away from each other. Let's look at frequency charts and histogram in our next video.